Hi everyone, we are here to go over how we can use our area model to multiply integers. Okay, so let's say that we have, make sure that everything's going to fit. Let's say that we have 57 times 49, all right, and I want to find the product of 57 times 49. So I'm going to use what I know about area, which means that my area can be found multiplying my length and my width of my rectangle to solve this. So I'm going to draw my area model. I have 2 digits in my first factor and 2 digits in my second factor. So I need to have each side split into 2. I'm going to write 57 in expanded form. My ones come first, so I have 7 ones and 5 tens, which would be the same as 50. For 49, I have 9 ones and 4 tens, which would be 40. All right, so now I'm going to go ahead and solve. Remember, we're going to use our length and our width. So our length for this rectangle right here is 9. My width is 7. 9 times 7 would give me 63. For this one, my length is again 9. Here's where that length is. This part right here is represented by that 9. So I'm going to do 9 times 50. 9 times 5 gives me 45. And I'm working with tens, so I have 45 tens or 450. Going down here, I would do 40 times 7. 4 tens times 7 would give me 28 tens or 280. Lastly, I have 40 times 50. 4 times 5 is 20. And my 10 times my 10 would give me hundreds or 2,000. So now that I have my 4 partial products, I'm going to go ahead and combine so that way I can get a final product. I'm going to go ahead and add straight down first. So 63 plus 280 would give me 343. 450 plus 2,000 would give me 2,450. All right, and now I'm going to combine these. You could have also written all 4 of them up and down because remember that our addition is commutative, so it does not matter the order of my addends. All right, so all together we would get our final product of 2,793. Let's try one more. And we're going to look at a 4-digit by 1-digit because that would mean that my area model looks a little bit different. We'll look at standard algorithm for this one as well. So if I have 3,284 and I'm multiplying that by 5, that's kind of a messy multiplication. Let's see, making it all work, 84 times 5. All right, so when I'm drawing my area model, this one looks a little bit different because I have 4 digits in this first factor. So I need to make sure I have 4 sections, and then I just have 1 digit here. So I don't need to do anything else because I just have that one place. All right, so my 5 is going to go here. I'm going to write 3,284 in expanded form. And then we're going to go ahead and multiply just like we did for our last one. 4 times 5 gives me 20. 5 times 80. 5 times 8 is 40, and I'm working with 10, so that gives me 400. 5 times 200. 5 times 2 is 10, working with hundreds, so that gives me 1,000. And 5 times 3,000, 15,000. All right, now let's look at the similarities between our standard algorithm and our area model. So when I do my standard algorithm, 3,284 times 5, where this comes into play in terms of where we have similarities is how we add. So let's go ahead and put all of these partial products together. So I have 20 and I have 400, and I have 1,000, and then I also have 15,000. All right, So just like normal, we normally add these partial products up, but let's see how it's similar. 4 times 5 is 20. I'm going to bundle those 21s into 0 1s and 2 10s. That's the same here. I have 0 plus 0 plus 0 plus 0, and my 2 is carried over here. 8 times 5 gives me 40 10s, plus those 2 10s from before to give me a total of 42 10s. I'm going to bundle those 40 10s into 400s, just like what we did here. 2 times 5 gives me 10 hundreds, plus those 4 hundreds from before gives me those 14 hundreds. I'm going to bundle that 10 hundreds into 1,000, just like what I did here. Then lastly, 3 times 5 gives me 15 thousands, plus 1 would give me 16 thousands, just like what I have here. So remember, friends, the main difference is that in area model, I multiply, 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 and then I add. And in standard algorithm, I multiply, add, multiply, add, multiply, add, multiply, add. Both are great strategies to help you solve these multiplication problems. All right, friends, I hope that this was helpful. And as always, please let me know if there's anything I can do to help. Thanks so much.